With these three examples, we start to look into the matrix functionality of Excel, how we can use Excel to perform simple matrix operations, as well as how to use matrix to solve systems of linear equations. But first, we need to do a little bit of review on matrix. A matrix is a rectangular array with elements or entries organized inside. The elements can be real numbers, symbols, or mathematical expressions. The size of the matrix is specified by the number of rows and number of columns it has. For example, this matrix has the order of m by n, or we say that this matrix has dimensions m by n because it has m rows and n columns. In this representation, you see this is subscript 34 for this particular entry. The subscripts specified the location of this entry inside this matrix. So the first number 3 specifies that this entry belongs to row 3, and subscript 4 specifies that this element belongs to column 4. Shown here are several examples of matrices. Matrix B is a 3 by 3 square matrix because it has 3 rows and 3 columns. So if a matrix has the same number of rows and columns, it is a square matrix. Matrix C is a 1 by 4 row matrix. It only has 1 row but 4 columns. Matrix D is a 4 by 1 column matrix. It has 4 rows but only 1 column. And lastly, matrix I is a 3 by 3 identity matrix. Identity matrices are all square matrices. It can be 3 by 3, 4 by 4, 5 by 5, etc. What's special about identity matrix is that they have elements of ones on their main diagonal and zeros for everywhere else. Now let's look at matrix operations. First, addition. Two matrices A and B can only be added together if they are of the same order, and their sum matrix will also have the same order. For example, if matrix C equals to A plus B, then every entry in matrix C equals to the sum of the corresponding entries in A and B at the same position. So if we add these two matrices together, all we need to do is to add the corresponding elements together and keep the sum at the same position. So 0 plus 1 equals to 1. That'll be the very first element on the first row and first column for the sum matrix, and etc. And this is what we get. Subtraction works the same way. Again, you cannot subtract one matrix from the other if they are not of the same order. We also have the scalar multiplication, in which case we multiply the corresponding elements together from two matrices, again of the same order. The scalar multiplication has this operator of a dot. And similarly, we have scalar division that works the same way as a scalar multiplication. And then a scalar can be multiplied to a matrix. In that case, we simply multiply the same scalar to all elements of the matrix. And then we have something a little bit more complicated, the matrix multiplication. It has the operator of a cross instead of a dot. In order to perform matrix multiplication, it must be obeyed that the two inner dimensions of these two matrices must be the same. Therefore, I can perform this matrix multiplication. However, I cannot perform this matrix multiplication when I switch the two matrices, because in the latter case, the inner dimensions of the two matrices are not the same. And this is the product matrix, and it has an order of 4 by 3, and that corresponds to the two outer dimensions of my two original matrices. So it looks complicated, but all you're doing is you're taking the entire first row of the first matrix and then multiply that by the elements of the first column of the second matrix and add them together. And that's the very first element of this matrix. And then you keep doing that. You take the second row, you multiply these two elements by the two elements in the first column of the second matrix, and that becomes your matrix element on row number 2 but column number 1, and you keep going. So as you can see, all the elements in the rows of the first matrix keep their row number, and all the elements in the columns of the second matrix keep their column number. Last thing I want to introduce is the inverse matrix. Inverse matrix only occurs for square matrices, and not all square matrices have inverse matrix. So if a square matrix A has an inverse matrix A -1, then it satisfies that the product of A and its inverse matrix, doesn't matter which order, must be I, and I is the identity matrix of the same order as A. So how do you determine the inverse matrix of A? So we can start this way by forming an augmented matrix. So basically we just put original matrix A and its corresponding identity matrix I side by side, and then we start to perform matrix row operations until the very left side is the identity matrix I, and then the right side is the inverse matrix A -1. And now we're ready to talk about how to use matrix to solve systems of linear equations. So for example, here you have a system of 3 linear equations, and if you're familiar with matrix multiplication, you know that mathematically this means the same thing as this. So you have a square matrix containing all the coefficients on the left-hand side of your equations, and that multiplied by a column matrix containing the unknowns x, y, z, and that equals to the product is a column matrix again, and that contains all the constants on the right hand side of your equations. And then from here, the column matrix x, y, z can be solved by taking the inverse of the coefficient matrix and multiplied by the product matrix. And as you can see, this method only works if your 3 equations are written in this order. So you have all your unknowns on the left hand side, the unknowns are in the same order, and all your constants are on the right hand sides. So this is the method we're going to use in softwares such as Excel and MATLAB to solve systems of linear equations. So now let's look at problem 26. We have 2 row matrices X and W. Both of them are 1 by 5. They have 1 row, 5 columns, and we need to perform a simple calculation to determine matrix Y that equals to 0.5, a scalar multiplied by matrix X, and then subtract matrix W from it. So to write matrices in Excel is very intuitive. We have 5 elements in matrix X, therefore we simply type in the 5 elements in that order. And let me give it a background color to show that this is a matrix. And then W, we type that in the same way. Again, give it a background color. Okay, so now to determine matrix Y. When you do matrix operation in Excel, something you need to know is that before you perform the matrix operation, you need to already know the size of your final answer. So in this case, because I am doing these type of simple operations, I know that my final answer, my matrix Y, has to be also a 1 by 5 row matrix. So you will not be successful if you don't already know that information. Therefore, let me give it some background. And then what I'm going to do is I'm going to highlight this entire row and then start typing equals to X matrix 0.5 multiplied by the X matrix, and then minus the W matrix. Now, you cannot simply hit enter. That will not give you the right answer. So actually, that will give you the right answer, but only 1 element. Therefore, you need to type in, you need to hit on your keyboard Control Shift and enter. So again, that's Control plus Shift plus enter. And that's the answer for matrix Y. You can also do it a different way by naming your matrix. So when I highlight these 5 cells, I can come over here and type in X. So now these 5 cells belong to a matrix that's called X. I can do the same thing for W. And then here, let me clear this. Again, I can highlight this entire thing and name it Y. And now Y equals to, still need to highlight everything, 0.5 multiplied by X minus W. And then I have to do Control Shift and enter. It will give me the same answer as well. So that's problem 26. Continue on to problem 27. So I have matrix A. This is a 2x2 square matrix. So I'm just going to type it in that order. Very straightforward formatting. Give it a little bit of background color to show that it's a matrix. I have a matrix B, 6, -5, 2, 12. And then a matrix C, put it here. That's -3, -9, 4, -5 here, 8, 6. Give it a little color. So if you want to, you can name them again. So this is A, this is B, and this is C. You don't have to do that. All right, moving on with the calculation. So the first one is A plus B. So again, I need to already know the dimension of the answer. So the dimension has to be a 2x2 matrix. Therefore, I highlight this part right here. And then, so this equals to A plus B. Control Shift enter. Similarly, A minus B. Highlight this part right here. This equals to A minus B. Control Shift enter. Okay. The dot product, I'm going to use this symbol dot multiplied by B equals to, remember that would simply be the multiplication of each element of these 2 matrices A and B. So that equals to A simply times B. We have a special operator in Excel for matrix multiplication. So if you simply type in the multiplication symbol that we're so familiar with, that is a scalar multiplication. Control Shift enter. So as you can see, each element of matrix A and B in the corresponding position get multiplied. So -7 times 6 becomes -42, and this is the first element. 16 times -5 becomes -80. That's the next element, etc., etc. And then similarly, A dot divide by. So again, this is simply equals to the division of each corresponding elements in matrix A and B. So A divided by B. And then for 2 times A plus 3 times B. So again, it has to have the same size. So this equals to simply 2 times A plus 3 times B. Now, lastly, the cross product of B and C, that's different. Now, B is a matrix of 2 by 2. C is a matrix of 2 by 3. So the 2 inner dimensions are both 2. Therefore, you can multiply them together. Therefore, to perform cross product, so we have B cross C. We use the X to represent cross. So you cannot do simply the multiplication sign, because that will give you the scalar multiplication as we demonstrated earlier. So to do that, first of all, you still need to know the dimension of the product. So this is a 2 by 2 multiplied by 2 by 3. Therefore, the product is going to be 2 by 3, according to the matrix multiplication rule. And then you need to call in a matrix building function that is MULT, MULT. That stands for matrix multiplication. So this takes in two arguments, matrix B and matrix C. My naming of matrix C was not successful earlier, so I had to rename that to M_C. And now, don't forget, it's Control-Shift-Enter. And that's the product of matrices B and C. So I have named many matrices in this example, but what if you want to change the names or you want to delete some of the names? You can go to Formulas and then Name Manager. So as you can see, these are the names that have been given to those groups of cells in Excel to make them specified matrices, but I can change them, or let me just go ahead and delete them, which is probably not a good idea, because as you can see, I called those named matrices in my calculation. So when the names no longer exist, my calculation is no longer valid. But of course, you don't have to name a matrix in order to do the calculation. For example, if I want to find the product of A and C, I can do that because matrix A is 2 by 2, matrix C is 2 by 3. Therefore, the inner dimensions are the same, and therefore the product will have the dimension of 2 and 3. So it's a 2 by 3 matrix. And I need to call the MULT function. And then I don't have to name anything. I can just highlight matrix A and then highlight matrix C. Don't forget Control-Shift-Enter. And that's the product of matrices A and C. So either way you want to do it. Okay. Lastly, for problem 28, to rewrite the following linear equations into the matrix form, that is, we have a coefficient matrix that contains all the coefficients on the left-hand side. So 1, -2, 3, and then 2, 5, -3, -3, -1, 1, and that multiplied by an unknown matrix. This is not involved in calculation. It's really just notes here. And that equals to the constant matrix. In this case, the constants on the right hand side of the equations 4, -1, -11. So this is the unknown matrix, and this is the constant matrix. Okay, so this is the matrix multiplication form of our original system of 3 linear equations. Now, to solve for our unknown matrix, we need to first find the inverse of the coefficient matrix. And we know that inverse matrix and the original matrix, they are both square matrices, and they must have the same dimension. Therefore, the inverse matrix must be also 3 by 3. So we highlight this part right here, and that equals to, we calling the Excel built-in function M inverse. We're trying to find the inverse matrix of this coefficient matrix. So I'm just going to highlight all of them instead of naming it officially. And then don't forget to Control-Shift-Enter. And that's the inverse matrix. And to find our solution, our solution will be a 3x1 column matrix, and that equals to the matrix multiplication of the inverse matrix and the constant matrix. Control Shift Enter. And that's the final answer. Therefore, x equals to 4, y equals to -3, and then z equals to -2. So that's how you use matrix in Excel to solve system of linear equations. You can use this method to solve system of more linear equations, for example, 5 equations, 6 equations, etc. And you can combine the steps as well. So you can directly highlight this 3x1 column matrix, and that equals to M multi, and then M inverse, and then your coefficient matrix, and then your constant matrix. So you're doing a nested function, and you will get the same answer.